Hi. Welcome to another edition of Stephen's Advantage and Advantage Scientific Educational Videos. Today's topic is earthquake. Seismic casework fabrication and installation requirements. An earthquake of any level can be physically devastating to your building construction and cause emotional foreboding for people residing and working inside. Some interesting headlines of recent articles on the topic. Earthquake maps reveal higher risks for much of U.S. New government maps extend hazard zones in eastern, central, and western U.S. According to a recent study, nearly half of Americans live in areas prone to earthquakes. Is it possible to build an earthquake-proof building? The answer is yes and no. There are, of course, engineering techniques that can be used to create a very sound structure that will endure a modest or even strong quake. However, during a very strong earthquake, even the best engineered building may suffer severe damage. Engineers design buildings to withstand as much sideways motion as possible in order to minimize damage to the structure and give the occupants time to get out safely. Buildings are basically designed to support a vertical load in order to support the walls, roof, and all the stuff inside to keep them standing. Earthquakes present a lateral, or sideways, load to the building structure that is more complicated to account for. What does all of this mean for the Stevens Industries casework you are putting into these buildings in earthquake seismic zones? For the AWI, AWS Edition 2, dated 2014, page 390, titled, Seismic Fabrication and Installation Requirements. Within the U.S., seismic fabrication and installation requirements are governed by the International Building Code, subject to any applicable state and local requirements that might be more stringent for the project location. Within Canada, they are governed by the National Building Code of Canada, Section 3.8, Appendix A. For more information, contact the National Research Council Canada at www.nrc.ca. Also refer to pages 327 through 332 for installation compliance requirements. Stevens Industries casework designs follow AWI, AWS standards for the mounting rail location, types and integration into the cabinet structure. Stevens casework would come under the non-structural hazards risk category in a seismic design, which the licensed structural engineering firm would take into consideration for the site earthquake design plan and would further assure by a follow-up quality assurance program that the plan was fully implemented. Stevens provides worst-case weight assessment as follows for the calculations by the licensed structural engineer of the motion forces involved, related to the casework and subsequent fastener types, quantities, and locations to attach, secure and restrain. Stevens has calculated the weights of typical largest cabinets for a typical base, wall, and tall cabinet for you to provide to the structural engineer who must design and approve the types, locations, and engagements of the fasteners for your job. Stevens used the integrated kick in these calculations. If a separate base is used, Stevens would provide 3/4-inch thick CDX plywood, as required. You should let the engineer figure this out, as his design would impact the weights involved. Stevens would try to provide the integral kick for all seismic-related jobs. Wall cabinet used for these calculations would be in inches, 13 deep by 48 wide by 30 high, with a pair of doors and 2 adjustable shelves and would be approximately 127 pounds. Base cabinet would be in inches, 24 deep by 48 wide by 36 high, with a pair of doors, single drawer and 1 adjustable shelf and would be approximately 209 pounds. Countertop at 1 inch thick for the base would be 25 by 48 and would be approximately 36 pounds. Tall cabinet would be in inches, 24 deep by 48 wide by 84 high, with a pair of full-height doors and 5 adjustable shelves and would be approximately 445 pounds. Stevens is sure these weights are all to the heavy side. The density of the cores in particle board do vary from 48 to 50 pounds per cubic foot, depending on the mill, so being to the heavy should provide more than adequate fastener recommendations from the structural engineer. Of note, Stevens Industries Incorporated has a vested interest in earthquake awareness because the plant is located in one of the exterior risk zones of the New Madrid seismic zone in Missouri. Please contact Stevens Engineering if more finite information is required. This topic is very complicated, and the previous information gives only an overview of the issues.